Good day. I am Kenneth Bolima from B5B, and today I will be performing laboratory experiment number 4 entitled HMI programming using Siemens TIA portal. So let's open up the TIA portal version 14 and run as administrator and click on yes. Pagod na ako. Okay, let's wait for the application to open up. Then let's create a new project like HMI Siemens. Siemens na lang. Siemens. Then create. And then once it's created, we'll be going to device and networks. And then add new device. And then controllers, then Simatic S7 1200, then the unspecified CPU, then open up that controller folder. Then once it opens up, we will be setting the inputs and outputs of the PLC. First, let's detect. Then, yeah, and start search. Then once we've detected the PLC, yeah, click on detect, and then we can now work with the PLC. Okay. And then let's set the input and output properties of the ang tawag nito? Ang tawag nito? The attachment of the PLC, and the starting address for that is 20 up to 2.75, and the output is the same, 2.0 up to 2.75. Then right click the PLC and then download hardware configuration to PLC. Tonight, and for this experiment, we will be doing a sorting system. We will be doing a sorting system that would sort metal from non-metal. So let's start with the ladder diagram and go to program blocks, then add new block, then function, then okay. Then let's first set the main. Let's add the block 1 to the main ladder. This one. Let's add the block number 1, block underscore 1. And now we can proceed to creating our ladder diagram. Okay. First, let's start with the emergency push buttons and push buttons. The address for that is for the for the push buttons for the stop. The address is I0.1. Then next is for the next is for the virtual push button for the stop with the address of M0.1. Then for the emergency stop, the address is I0.3. And then for the virtual emergency stop, the address is M0.3. Now, for our start push button, the address is I0.0.0, and then in parallel with that is a virtual start push button with address of M0.0. Okay. For the output is the supply cylinder, the extent of the supply cylinder extend. Let's place an output with an address of Q0.0. Then let's connect this first. Then let's place an normally closed contact for the let's just place that later. Now let's place a latch for our system Q0.0. Normally closed contact Q0.0. And now for our next branch is for the drill, so that once the supply cylinder extends, the drill will start. So the output and the starting condition for that is the extension of the supply cylinder. Then the read switch of the supply cylinder when it extends, and the address for that is I0.7. And then the let's also place a normally close for the stopping of that branch. Then the output is the drill, which has the address of Q1.0. Okay. Now, let's place a latch for this, and the latch is the drill, which is Q1.0. Okay. Mhm. Okay, once we've latched that, let's proceed with the next branch, which is for the drill cylinder going down. So the starting condition for that is when the drill starts Q1.0, and then the normal, and then a normally close contact, and then the output of the drill cylinder going down with the address of Q0.2. Yeah. Then let's place a latch also. Q 0.2. And then let's proceed with the next branch, which is the drill going up. The condition for that is once the drill went down, which is Q 0.2, and also the the reed switch of the cylinder, which has the address of I 1.4. Zero point. Now let's continue. A normally closed contact for the reed switch when the drill goes up, I 1.3, and the output is the drill cylinder going up with the address of Q 0.3. Then let's place a latch Q 0.3 and connect that here, and then let's proceed with the next branch, which is the retracting of the supply cylinder. And the opening condition for that is that the drill went up to 0.3, then a normally close for the the next cylinder expanding to 0.4, then the output of the retraction of the supply cylinder, which is the address of Q 0.1. Now let's also place a latch. Place a Q 0.1. Then connect that here. Then let's proceed with the next branch. And that's for the transfer cylinder, wherein the material will be transferred from the drill part onto the conveyor. And let's start with the opening condition, which is the last part, the supply cylinder retraction with the address of Q 0.1, and also the reed switch that verifies that the supply cylinder is retracted with the address of I 1.0, and then a normally closed contact of Q 0.5, and then the output Q 0.4, which is the transfer cylinder, and then a latch Q 0.4, then next is for the retraction of the transfer cylinder. So first let's add the start starting condition, which is the expansion of the transfer cylinder. Then a normally open contact for the reed switch of that transfer cylinder with address of I1.2, and then a normally closed contact for the conveyor. The address for that is Q1.1, and then an output of Q0.5 for the retraction of transfer the transfer cylinder. And let's place the latch for that Q0.5, then connect that here to this part of the circuit. Now we can proceed with the conveyor, the circuit for our conveyor. Let's start with the opening condition, which is the retraction of the supply cylinder. Then another normally open for the reed switch with address of I1.1, and then a normally closed for our photosensor. The address for that is I2.4, and then the output is the conveyor, address Q1.1. Then put a latch, here, then a contact Q1.1. Then connect that to the circuit. Then for the distributor cylinder, let's place a branch and then a opening condition, which is the starting of the cylinder, and another one for the metal sensor with the address of I0.6, and then a normally close for the photoelectric sensor to stop the conveyor. Again, the address for that is I2.4, and then the output is the distributor cylinder A. The address for that is Q0.6. Then let's add a latch for that 0.6. Then drag it here. And now for the last part of our system, the distributor cylinder B, which would be for the non-metal. And then the starting condition is that the like for the metal one, the conveyor must be running. And then we have the sensing a blue sensor that would sense if the material is non-metal, and the address for that is I2.3. Then a normally closed again for the photoelectric sensor. The address is I2.4. And then the output is the distributor B. With address of Q0.7. Then let's place a latch Q0.7. Okay, we're done with all of our conveyor ladder diagram. Let's proceed with our lighting, the lightings for our system, the tower lights and pilot light. So first is for the start push button addresses. The address for that is I0.0. Once we press start, the pilot light must be green, and the tower light is also green. The output is Q2.0, and in parallel with that is Q2.4. Now, to stop this, to stop the light of the start push button, the stop push button must be pressed, or the emergency stop push button. And the address for that is I0.1 or I0.3. Let's also add the photoelectric sensor for this one, so that when once the cycle completes, the green light of the green tower light and pilot light would go back to the standby light, which is the orange light. So I2.4. Then let's place a latch for this. Let's also place our virtual start push button here in parallel, so that we can use it at the HMI later with the address of M0.0. Okay, for our stop push button, let's create a branch for the stop push button. The address for that is I0.1, and what can the condition that would stop the the light for the stop push button is the emergency stop, which is I0.3, as well as the push button for the start. Let's place that here, I0.0, and let's also add the virtual push buttons here, M0.1 and M0.3. M0.0 and M0.3, and the output for this one is the yellow the yellow tower light and the red pilot light. So the address for that is Q2.5, and in parallel with that is Q2.1. And let's also put a latch here for the Q2.5. Okay. Let's also add a constant yellow tower light that can only be stopped by the push buttons. First is the stop light, the start light, which is I0.0. Then next is its virtual push button, which is M0.0. Then the drill up Q.3, Q0.3, the tower light red, which is Q2.6. The output is the yellow tower light Q2.5. And lastly, for our emergency stop, we have the push button for the emergency stop, which is I0.3, and its output is the tower light of Q2.6, and also the anong address yan? Anong address yan? Yung stop,
Push button.
yung emergency stop.
Emergency stop. IO3.
Hindi, yung ano, output. Sa output, Q,
Emergency stop. Stop. Q.
stop, E-stop, 2.3. Yan. Okay. Okay, that's the end of our ladder diagram. Let's proceed with our tags. Okay, add new tag table. Ay, wala, default tags. Okay, let's start naming these tags. I1.0 is for the physical stop. Then M0.1 is the virtual stop. I0.3 is the physical e-stop. The M0.3 is the virtual e-stop. And I0.0 is for physical stop. M0.0 is for physical start. Physical start. Then M0.0 is virtual start. Then is for the tower light of red. And lastly, Q2.3 is for the pilot light of the e-stop. And that's everything. That's all of the tags that is for our system. Then save. Let's save first for our progress. And then let's upload this or download this to the PLC. Then continue without synchronization. The action is stop all, then load. Then once it's done downloading, we can test it out first. It's working. Is it working? Then okay, it's working. Now let's proceed to creating our HMI program. So let's first click save here. Then new here. Let's close this first. Let's open up the portal once again. And While it's opening up, I will transfer the Ethernet cable from the PLC to the HMI screen. Ito. Yan. Okay. Let's open up our project. And then go to device and networks, and then add new device, but this time for HMI. It's a basic panel with 4-inch display and KTP 400 basic with 6AB2123, and that's our HMI. And then once it's open up, we can edit our HMI. Haba nito Pagpingin. And let's browse the PLC underscore one, then check, and then let's just see the other. I won't change anything here. Then click finish, and then yeah, we can now proceed to editing our layout for the HMI. Select this. Then let's add some lights for our red, green, and blue pilot lights, and three buttons as well. Let's place this first. Then some push buttons for each. Copy. This is for start. Copy this. Copy this. Paste. This is stop. And then paste. And this one is e-stop. Let's link the tags that we have created. Go to events, and then press, and then add function, then set bit while key press. Then the tag for that is the one that we've created earlier from the PLC tags, and that's the virtual start, I mean. Click and check. Okay, let's edit this first. Play, check. And then for our stop, add function. The function is set bit while key pressed also, and the tag is add new, and then wait, let's go to the PLC tags, and then virtual stop, then click on check, and then for the emergency stop, add function, set bit while key press, and then the tag for that is the virtual emergency stop. Okay, for our lights, the animation is display and appearance. And the tag name for that is tower light. I mean, tower light. Then add new. When it's off, the color is black, and when it's on, the color is green. And for the orange light, the same as the green light, the tag is tower light red. And then add new. Off is black, on is red. And let's check this first. This should be tower light green, not tower light red. Tower light green. And then lastly, for our emergency stoplight, the I'm I'm messing this up real bad. This is orange, and this should be also be orange. This is orange, TL orange or yellow, and then for the last one it's red. And add new. When off it's black and on is red. Okay, let's go to HMI tags and new group table. Then let's see the default tags. Let's edit this first. Let's set this all to the access mode. Let's set all of the access mode as absolute access so that it will be connected to the addresses of the PLC. Absolute access. Then let's click on save, and then let's upload this to the HMI. Let's download this, to the HMI screen. Let's start search. Search. When it's detected, let's click on load, and then once it's loaded, we can now test the HMI and the PLC together. Overwrite this, then load. Yeah, load complete. So I'll test this out first if it's working. Let's connect the HMI to the PLC and let's wait. Start. Go. Okay, there's a problem with our tower lights, so let's edit that first. Let's edit our tower lights first. From our PLC, edit the tower lights.
Like
Ingat po. Let's open up our block diagram again and then edit our ladder because the tower light is messing up. So emergency stop is red, tower light is on unless tanggalin ko na kaya ito. Should I just remove this one and add this one here? Then shouldn't be this one. They should be emergency stop, which is I0.3, and let's just remove this one. Or should this one be the one remove? Let's test it out first. Okay. Let's upload this. This directs. Is it summertime? Then load. Okay. Wait, error found. What's the error? Ito. Compile if there's a problem. Okay, download to PLC. And then let's test. Okay. Let's test the out the HMI. Let's see. Okay. Start. Stop. Okay, so the virtual emergency stop and start is not working, and I know why, because we didn't add that here. So let's edit this out first. Edit this and add the virtual stop, which is M0.1, and for this one the virtual emergency stop, which is M0.3. Okay. Let's download this again to our PLC. Yes, rewrite. Okay. Then connect this again to our HMI. And then test it out first. Yan. Okay, good. It's working, so let's first fix this conveyor system. Let's add the cartridge and the bullets. and it's video proof for for purpose that it's same time. Video, it's yeah, no, stop. Then press here. It works. Then let's just speed this thing up. Then let's try this stop. We can stop it here. And then press start again. We can stop it using this. And then the emergency stop. And that's all for this sorting system.